Okay, welcome back. We've got this distance function, s of t equals t squared. We want to find the general expression for the average velocity over the interval 1, comma, 1 plus h. So remember, we've got ordered pairs here. We've got an ordered pair in which we have 1, then we have an ordered pair 1 plus h is the x value. So when I put a 1 into s of t equals t squared, when I put a 1 in for t, I get a 1 out, right? 1 squared is 1. So 1, 1 is one of our ordered pairs. And then 1 plus h is the end of the interval, so that's the x value. When I put 1 plus h in, I get 1 plus h quantity squared, which is 1 plus 2h plus h squared. That's a trinomial. 1 plus 2h plus h squared. I better use a different color. So we get a 1, and then we get 1 plus 2h plus h squared. And there's our inputs right there. Okay, so our average rate of change is going to be our change in y, right? Our change in y over our change in x. So our change in y, let's start with this second ordered pair. So we've got 1 plus 2h plus h squared minus 1. Okay, here's that minus 1. And then we've got 1 plus h minus 1. Now we can simplify that. 1 minus 1 is 0, so we've got 2h plus h squared over 1 minus 1 cancels out over h. Well, I'm going to factor an h out of the numerator, which is going to give me h times the quantity 2 plus h over h. And now these two h's cancel, and our average rate of change for our velocity is 2 plus h. So it all depends on what h is. Whatever h is, the average rate of change would be 2 plus h. Now that gets us into this difference quotient. Since we're working with variables here, the difference quotient. The difference quotient is just an average rate of change. Right? It's just an average rate of change. So here we've got our function defined, f of x equals x squared. We want to find f of x minus f of 5 over x minus 5. So notice how your inputs x, 5, and then your inputs are your x values, x minus 5. And then x, a, and then x minus a. Remember that f of x is your y value, f of 5 is your y value, so your change in y over your change in x's. What is f of x? Well, f of x is equal to x squared. So everywhere I see f of x, I can put an x squared in its place. What's f of 5? Well, f of 5 is equal to 5 squared, which is 25. So everywhere I see f of 5, I can put 25 in its place. X is a variable, minus 5. Let's see what we get. So in place of f of x, I've got x squared. In place of f of 5, I've got 25. And then we've got over x minus 5. Now we just have a rational expression that we need to try to simplify, which we can simplify. X squared minus 25 factors to be x plus 5, x minus 5, over the binomial x minus 5, which is a common factor now to the x minus 5 in the numerator. So our difference quotient is x plus 5. Okay, let's try that again. Here we have g of x equals x squared plus 3. Well, what is g of x? It's x squared plus 3. So everywhere I see a g of x, I can put x squared plus 3. And then g of a, what's g of a? Well, g of a is a squared plus 3, right? Everywhere I see an x, I put an a in its place. So in place of g of a, I can put a squared plus 3. So we're going to have x squared plus 3, that's our yellow function, minus all of the green function, and all of the green function is a squared plus 3. And then in the denominator, we have x minus a. So let's do some work here. X squared plus 3 minus a squared minus 3 all over x minus a. Well, plus 3 minus 3 cancels out, and we have x squared minus a squared over x minus a. Well, x squared minus a squared is factorable. It's x plus a times x minus a, and that's over the binomial x minus a. The x minus a's cancel, and we're left with just x plus a, which is our answer. Okay, here is another example. I'd like to see if you can try this one. Let's see if you can try this one. Press pause, and then come back, and you can watch me do the work. Okay, f of x is simply 2x squared minus x plus 1 minus all of f of a, which is 2a squared minus a plus 1. And that's going to be all over x minus a. I may run out of some room here. I'm going to have 2x squared minus x minus 2a squared plus a. The 1 minus 1 cancels, and that's over x minus a. I'm going to factor out an x, and that's going to leave me 2x minus 1. Factor out an a, and that's going to leave me 2a plus minus 1. I don't think I want to line them up that way. Let's see what we got here. We've got 2x squared minus x minus 2a squared plus a. This one's going to be an interesting one to factor. So we've got a challenge here. Let's rearrange this a little bit. So you could tell it looks pretty interesting. Like they got something in common here, right? When that happens, just don't give up. Reorganize. I'm going to use all this work right here. I'm going to need this space because this factoring is going to be interesting. So I'm going to factor out a 2, and I'm going to get x squared minus a squared. And then I'm going to factor out a negative 1, and that's going to give me x minus a. And then I'm thinking, wait a second, I've got an x minus a. I've got an x minus a right here. I know I do, because if I factor that, watch. I've got x minus a, x plus a, right? Minus 1 times x minus a. This is why factoring is so important. Now, there's 2 terms here. This is all connected by multiplication. This is connected by multiplication. And I've got 2 different terms, and they both have an x minus a in common. This is factor by grouping. So I'm going to factor out that x minus a. So in the I'm going to factor that x minus a out. And then what's that going to leave me? It's going to leave me 2 times x plus a minus 1 all over x minus a. Okay, so I factored out this x minus a. Factored it out because it was common to both of them. And this is where it went. It went right there. And then what was left over? This 2x plus a. Here's your 2x plus a. And what else was left over? Right here, when I factored it out of here, just this minus 1 right there, that minus 1. And now, beautiful, this x minus a cancels out with this x minus a because they're common factors. And that's going to leave us 2 times the quantity x plus a minus 1. Now I'm going to distribute 2x plus 2a minus 1. 2x plus 2a minus 1. And there's nothing else we can do there. We just box it, and that trinomial is our answer. So that was some good stuff there. Good stuff. Okay, see if you can try this one. It looks a little bit different, but it's actually almost a little easier because you don't have a binomial in the denominator. Just take your time and see if you can figure out what f of x plus h is. We already know that f of x is 2 over x. But what's f of x plus h? Press pause, try and find out, and then come on back and check. Okay, if you're watching, you've hopefully tried on your own. F of x plus h is going to be 2 over x plus h. Everywhere you see an x, you're just going to put an x plus h. So that f of x plus h is going to be a fraction. So I've got 2 over x plus h minus, right? So I've done this, and now I'm at the minus, and now f of x, 2 over x. And then that's all over h. So here's my yellow part, f of x plus h, minus f of x, all over h. I'm going to put h over 1 because I have a complex fraction here. I've got a fraction within a fraction. I have to clear that fraction. So what's common to x plus h, x, and 1? The LCD would be x plus h. So I'm going to multiply each term by x plus h, x plus h. And yes, even this denominator, x plus h. The x plus h's cancel, and I'm going to have 2x minus the x's cancel, and I have 2 times the quantity x plus h. And then in the denominator, I have x plus h. I've almost run out of room here. I'm going to take this and I'm going to make myself small. I knew I was going to work into this next problem. Remember, I said, hey, I'm going to use some of this room. It's the wonderful thing about technology. You can just take your work and shrink it. Okay. Okay, so I'm going to move this up here. I'm going to distribute the negative 2. I've got 2x minus 2x minus 2h all over x plus h. 2x minus 2x cancels out. Negative 2 times h over x plus h. These h's cancel. And my final answer, negative 2 over x plus h. Now, the more we get into college algebra, the more important it is that you are getting comfortable, that you're already comfortable with the algebra that's involved. In some cases, there is going to be an intense amount of algebra, and you just got to persevere and work through it. You have to practice. The key is being honest with yourself, being honest with whether or not you get it, being honest with whether or not you understand, and you can go back and rework the problem on your own and go as fast as I can go during the lesson. So keeping up with me and understanding each step that I'm doing is super important. If you don't understand what we've done here algebraically, guaranteed it's in an earlier video. Guaranteed it's in an earlier video. Please do not shortchange yourself. Please give yourself that opportunity to go back, rewatch a video, pause a video, work a problem, the same problem a second time, so that you get more comfortable with the in-depth algebraic process that we're going through to get to our final answer. Usually that's the part that's going to trip you up. It's not going to be the idea of what we're learning. It's going to be the algebra that it takes to get to that end answer.